Hello, 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 my dear students. Am I audible? Audible, visible, hello. Hello. Hello, hello, yes. Hello, hello, hello. Perfect. Hello, 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 everyone. Hello. So, hi Navya. Hi Durga. Hi Lakshmi. Gia. It's not Lakshmi. Hello. Mika. Karch. Nagaraj. Yes, guys. So tell me, உங்களோட preparation எல்லாம் எப்படி போகுதுடா? உங்களோட hello. Yes, I'm good டா. So உங்களோட preparations எல்லாம் எப்படி போகுது? உங்களோட preparations எல்லாம் எப்படி போகுதுடா? உங்களோட preparations எல்லாம் எப்படி போகுது? சூப்பரா போகுதா? இல்ல நம்ம from here I can okay. So tell me. Yes, only 1.5 day. Yes, 1.5 days to go, ma'am. You can't say 1.5 day allada. So only 1 day is there, okay? So adukapra ungalku exam da. Okay. So yes, not good. Okay, enna aidichu? Not good ku reason enna? Durga, what happened? Hello ma'am, how are you? After a long time I am coming every day, okay? You are not coming, okay? That is the reason, okay? So guys, நமக்கு தெரியும் chemistryல important concept தான் reaction mechanism, okay? So reaction mechanism is very important. Normally நீங்க எழுதும்போது, okay? So organic chemistryல அவங்க எங்க twist வரும்னா மெக்கானிசத்துல தான், ஓகே? மெக்கானிசம் ரிலேட் பண்ணி வர்ற கொஸ்டின்ஸ்ல தான் அவங்க ட்விஸ்டா ஏதாச்சும் போடும், ஓகே? ஸோ திஸ் இஸ் வெரி 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 இம்பார்ட்டன்டா, ஓகே? ஸோ கைஸ், ஆர் யூ ரெடி? Ready for reaction mechanism? Guys, are you ready for reaction mechanism? Tell me quickly in the chat box. Guys, are you ready for reaction mechanism? If you are ready, just give me some fire in the chat box. Give me some fire in the chat box. How's physics going? So guys, உங்களுக்கு தெரியுமா இன்னைக்கு full night, okay? நாங்க 3 teachers வந்து உங்களுக்காக கிளாஸ் எடுக்க போறேன். ஸோ அந்த நைட் கிளாஸ்ல உங்களுக்கு பிசிக்ஸ்ல என்ன வேணும், கெமிஸ்ட்ரியில என்ன வேணும் சொல்லுங்க? பிசிக்ஸ்ல என்ன வேணும்? நைட்ல உங்களுக்கு பிசிக்ஸ்ல எக்ஸப்ஷன்ஸ் வேணுமா? இன்க்ரீசிங் டிக்ரீசிங் ஆர்டர் எல்லா எக்ஸப்ஷன்ஸும் வேணுமா? வேற ஏதாச்சும் வேணுமா? ஐ எம் பிளானிங் எக்ஸப்ஷன்ஸ், ஓகே? ஐ எம் பிளானிங் ஒன் எக்ஸப்ஷன் செஷன். வேற ஏதாச்சும் வேணுமா? வாட் யூ வாண்ட்? டெல் மீ கைஸ். நைட்டா? எஸ், கம்ப்ளீட் நைட் செஷன் இருக்கு இன்னைக்கு. ஸோ மேம் நைட், எஸ் இன்னைக்கு நைட்டடா கம்ப்ளீட், ஓகே? 7 to morning 5, ஓகே? 7 to morning 5 வரைக்கும் கம்ப்ளீட் செஷன் இருக்கு, ஓகே? கம்ப்ளீட் செஷன் இருக்கு. ஸோ குயிக்கா PYQ solving, more ma'am, okay? Most expected questions, okay? Most expected question. Ionic equilibrium, okay? So you want questions only, alle? So I thought I will give you exceptions. Do you want exceptions? Physical chemistry or the formulas, okay? Formulas venu, exceptions venu, and most concept, okay? Most important concept, okay? Most important concept, okay? Then what do you want? Yes, என்ன வேணும்னா அதுக்கு ஏத்த மாதிரி we will plan, okay? So அதோட பேசிஸ்ல we will plan, okay? Periodic trends, okay? Exception la adu periodic trends alla included da. Exceptions important, yes. Important exceptions I will give you, okay? No worries, I will give you Van Hoff factor. You want Van Hoff factor, okay? I will give you Van Hoff factor, but proper session paakano, okay? All the exceptions, okay? I am planning all the exceptions. Now important concept questions, okay? Okay va? And chemistry la ungalku enna venum? Chemistry physics la ungalku enna venum? Simple easy questions too, ma'am, okay? I will give you simple easy question to difficult level question, okay? Okay? So physical chemistry formulas you want alle. So physical, I'm planning physical chemistry formulas, and I will give you physical chemistry formulas. I will give you exceptions and PYQs. Okay, PYQs I will give. Okay, what you want. Okay, this iduvlo podulla. Physics la enna venumda? Physics la ungalku enna venum? Physics la enna venum? So here in the session la na included PYQs ellame include பண்ணிருக்கு. So adula irundhu ungalku analyze பண்ணலாம். Okay, இந்த மாதிரி PYQs வரும்னு. Okay, இந்த மாதிரி questions க்கு chances இருக்குன்னு analyze பண்ணலாம். So start பண்ணலாமா guys? Are you ready? Tough numerical practice. Okay, tough numerical practice. Okay, physics class la 11th problems. Okay, not direct, maybe questions varum bro. Okay, idu podula. Okay, start pannatuma. Most repeated question. Okay, most repeated questions ellame already koduthirukkullada. So anyway, we will plan some questions. And inorganic chemistry pannunga ma'am. Inorganic chemistry la exceptions I will give you. Okay, exceptions I will give you. Okay, inorganic chemistry la irundhe exceptions I will give you. Okay, so enakku theriyum ungalku ella exceptions venunu. So I will give you exceptions. So start pannalama da. So organic ipo start pannalama. Reaction mechanism start pannalama. So yes, so name. So we are, okay, I will teach you today. Na teach panna poradhu actually. So yes, so first one is reaction. Guys, listen carefully. So reaction mechanism. So reaction mechanism, which it's very important. Okay, reaction mechanism, rate of reaction, we will do practice. Okay, so in between that I will give you previous year questions. Okay, I'm giving only previous year questions. So I think you all are ready. So first we can start with elimination reaction. Ennada elimination reaction? So elimination reaction la actually two type of elimination reaction is there. One is E1 elimination reaction, another one is E2 elimination reaction. 2 hour la I will finish. Okay, E1 elimination reaction is there, E2 elimination reaction is there. So when you consider, we are going to discuss about E2 elimination reaction. So elimination na ennada? Anga irundhu eliminate agum, yaarachu anga irundhu pogum. Okay, that is elimination. Okay, so here you can see E2 dehydrohalogenation. So tell me guys, what is dehydrohalogenation? Tell me, what is dehydrohalogenation? Tell me quickly, what is dehydrohalogenation? Kyukka sollungada. Enada dehydrohalogenation? We know that elimination na enna? Anga irundhu and the molecule la irundhu some part anga irundhu eliminate aganum. Very good. Okay, so inga you can see E2 mechanism. Okay, E2 irukku, E1 irukku, removal of hydrogen and halogen. Very good. That is HX. Okay, so hydro na ennada? H, halogen na enna? X. So here we are eliminating hydrogen and halogen. Okay, so it is also called beta elimination. Okay, it is also called beta elimination, also alpha beta elimination. Okay, it is also alpha beta elimination. Clear? It is also called alpha beta elimination. So உங்களுக்கு டைரக்ட் இப்படி சொன்னா போதுமா, இல்லனா வேற ஸ்லைடு வச்சு எல்லாமே கம்ப்ளீட்டா எழுதணுமா? So வேற ஸ்லைடு வச்சு எழுதணும்னா I will write. Okay, so here alkyl halide ல இருந்து we are preparing alkenes. Okay, alkenes we are preparing. So from alkyl halide ல இருந்து we are preparing alkenes. Okay, so complete writing. Okay, I'm writing. So here you can see C. So one C contain halogen and one C contain hydrogen. Okay, so halogen and hydrogen is there. So edoda presence la inga reaction nadakum? One strong base oda presence la. Okay, a strong base oda presence la da inga reaction nadakudhu. So I will write here NaOH. Okay, NaOH is a strong base. Okay, NaOH is a strong base. Then what will happen? Yes, NaOH, KOH or base la. Yes, KOH is also possible. NaOH or KOH. Okay, alkali medium. Okay, alkali mediumத்துல தான் இந்த reaction நடக்குது. அப்ப reaction எப்படி நடக்கும்? So I'm taking a base. Okay, I'm writing normally B. Okay, so here I will write X. So here I will write X. So here I will write X, here H. So guys, we know that base means, okay, base oda charge and normally negative charge irukum, high electron density irukum. Okay, base la eppadi irukum, high electron density. So I am giving a negative charge. Okay, I am giving a negative charge. Then what will happen? So base inga vandu halogen attack panna mudiyuma, base ku inda halogen attack panna mudiyuma? It is not possible. Why? Because base is actually negative. Okay, so when you consider halogen, halogen la enna irukku? Halogen contain actually lone pair of electrons. Okay, lone pair of electron and negative பக்கத்துல வந்தா what will happen? Obviously repulsion will happen. Then what will happen? So base என்ன back side ல இருந்து தான் attack நடத்தும். Okay, back side ல இருந்து தான் base ஓட attack இருக்கும். Okay, so this is not possible. It's very important. It is not possible. Then what will happen? So inga base inda carbon poi attack pannu. Appa enna nadakkum? C inga B C here. So I will write, okay, I will write complete reaction. So inga already hydrogen irukku. Okay, hydrogen. So 1 2 3 hydrogen also there. So then what will happen? It's very simple. So bond formation and bond breaking simultaneous bond formation nadakku, bond breaking nadakku. Okay, yes, it's not Markovnikov's rule. It's not about Markovnikov's rule. Here it is alpha beta elimination. It is not Markovnikov's rule. Okay, it is not Markovnikov's rule. It is just alpha beta elimination. Okay, it is just alpha beta elimination. So enna nadakku? So inga இந்த carbon இந்த hydrogen தான் வந்து attack பண்ணும். Okay, just a second இந்த hydrogen தான் வந்து attack பண்ணும். Okay, I will draw. So இந்த hydrogen தான் வந்து attack பண்ணும். Okay, இந்த hydrogen வந்து attack பண்ணும். So inga hydrogen வந்து attack பண்ணும்போது what will happen? So simple, this bond will break. Okay, so normally, so in the bond breaking and bond formation I will write here. Okay, so this is okay, this is hydrogen, this is normal hydrogen, and inga irundhu enna pogum? I will use different color. Okay, I will use different color. I will use yellow. Hydrogen base double bond. Okay, alkene will form alle, appo double bond will form. So next enna nadakkum? Inga halogen irukku, so adu enna break agum. Okay, adu break agum. So here baaki ellame hydrogen. So yes, hydrogen is there. Okay, so here you can see at the same time bond formation and bond breaking is happening. Okay, at the same time bond breaking nadakudhu, bond formation nadakudhu. Yes, Saytzeff rule I will tell you. So bond formation nadakudhu, bond breaking nadakudhu. Okay, so here you can see BH la bond formation bond breaking BH la bond formation bond breaking BH la bond formation bond breaking Come on quickly. BH la bond formation bond breaking Come on, break. Yes. So BH la break nadakumla. Illada bond formation தான் நடக்கும். So inga bond formation. Okay, here you can see bond formation. So I am writing BF. Okay, so here, okay, inga hydrogen and carbon la, okay, bond hydrogen and carbon la in the bond actually break agudhu. Okay, in the bond actually break agudhu. So I am writing BB. Okay, so and in the double bond it is actually bond formation. So I am writing BF. And carbon halogen bond it is actually bond breaking. Okay, it is actually bond breaking. So simultaneously bond breaking and bond formation. This is not SN1. No, this is not SN1. This is elimination reaction. That is substitution reaction. So inga irundhu eliminate agudhu guys. Idudha romba important. Okay guys, it is very important. Okay guys, it is very important. Normally you guys will think, so ஒரு reaction பார்த்தா இது SN1 reaction இல்லனா SN2 reaction da normally we will think allada, but elimination reaction இருக்கு, addition reaction இருக்கு, substitution reaction இருக்கு, இதுல nucleophilic, electrophilic, okay, different type of again இதோட sub இருக்கு. Okay, it is actually very important. Organic chemistry proper ஒரு answer தெரியணும்னா, அதோட answer கிடைக்கணும்னா இந்த mechanism is very important. Okay, mechanismத்துல இருந்து lots of questions வந்திருக்கு. Okay, lots and lots of questions வந்திருக்கு. So yes, what will happen now? So inga bond formation nadakudhu and inga irundha bond break agudhu. So I am writing the product here. Okay, I will write the product here. So what will be the product? C double bond C. Okay, inga oru hydrogen irukku, ingeyo hydrogen irukku, inga irundha hydrogen என்ன eliminate ஆயிருக்கு, இங்க இருந்த halogen eliminate ஆயிருக்கு, இங்கேயும் one hydrogen, இங்கேயும் one hydrogen, and byproduct X minus கிடைக்கும், X minus கிடைக்கும், and இங்க BH கிடைக்கும். Okay, BH கிடைக்கும். Clear ஆ? So mechanism you should understand. Okay, concept clear ஆனா மட்டும்தான் அந்த ஆன்சருக்கு answer. Okay, அந்த questionக்கு answer எழுத முடியும். Okay, so I will take maximum 2 hours. Okay, I will take maximum 2 hours. Clear? Maximum 2 hours மட்டும்தான் இதுல எல்லா mechanismsம் finish பண்ணும். Okay, I hope it's clear. So guys, then I will give you some important point. Okay, mechanism irundha adula rate of reactions and important points are very important. So let's check. Okay, so important points of this elimination. Okay, alpha elimination reaction. Okay, good afternoon. Okay, this is very important. So here you can see no intermediate formation. Okay, inga intermediate formation illa. So what is actually intermediate formation means? Either cation or carbanion or carbon free radical formation, that is intermediate. Okay, here you can see a transition state. Okay, here you can see transition state only. Okay, and all 5 atoms involved in same plane. Okay, involved in same plane. So same plane I will tell you. So which 5 atoms? So that is a base. Okay, base, this hydrogen, this carbon, another carbon, and this halogen. 1 2 3 4 5. Okay, this 5 carbon should be in one plane. Okay, should be in one plane. Okay, next point, rate of reaction with respect to Rx. Okay, Rx oda basis la rate of reaction. Okay, on the basis of Rx சொல்லும்போது நம்ம என்ன சொல்லும்? Rx oda இங்க bond energy. Okay, iodine பார்த்தா it's a easy living group இல்ல, easily என்ன iodine அங்க இருந்து போகும் because size is high. Okay, and bond energy is also very less, so we can easily break the bond. So the bond, okay, the rate of reaction is actually more in Ri then RBr, RCl, RF. Okay, this is very important. This is actually rate of reaction with respect to Rx. Okay, and next is rate of reaction with respect to Rx da, and we know that rate of reaction is directly proportional to stability of alkene. Guys, what is actually stability of alkene means? So how we will calculate the stability? How we will identify the stability? Yes, this alkene is more stable. Just calculate number of alpha hydrogen. Okay, alpha hydrogen and different bases irukku. Okay, so normally you can check number of alpha hydrogen. Okay, next is base. This order, okay, we know that base and, okay, base and a alkyl halide is reacting, so order is actually 2. Okay, molecularity is also 2 here. Okay, molecularity is also 2 here. And more stable alkene is major product. Okay, more stable alkene. Okay, if you are getting 2 alkene, okay, so which one is more stable alkene? That alkene is what? That more stable alkene is a major product. And it is anti-elimination. Guys, what is anti-elimination? You can see here, base எங்க இருந்து attack பண்ணிருக்கு? Opposite side ஓட hydrogen. Okay, so yes, so opposite side எடா Markovnikov's rule na என்னடா? Markovnikov's rule addition la தான் வரும். Here it is elimination. Okay, this is elimination reaction. Markovnikov's rule na positive addendum எங்க வந்து attach ஆகும்? Carbon containing more hydrogen. So here attach ஆகல. So இங்க இருந்து eliminate ஆகுது. This is not Markovnikov's rule. Listen carefully. Okay, so yes. Then I want to add one more point. Okay, in case of bulky base, okay guys, this is very important. Okay, in case of bulky base, okay, so நாம already ஒரு base எடுத்திருக்கு. So base, suppose tertiary alkoxide. Okay, tertiary alkoxide na enna? It is bulky group. Okay, here you can see it's very bulky. Okay, 3 different groups. Okay, 3 alkyl groups are attached. So automatically bulkiness is more means we know that repulsion is more. Okay, repulsion is more means it is less stable. Okay, so here you can see in case of bulky base, less hindrance beta hydrogen will decide major products. So bulky group vandirukku nenichukonga. Okay, so bulky group vanda we know that. Okay, so there is 2 beta group. Okay, so idum beta da, idum beta da. Okay, so inga irundhu endha carbon enna endha hydrogen inga irundhu eliminate agum. My question is endha hydrogen. Okay, beta hydrogen ingeye oru hydrogen irukku, ingeye oru hydrogen irukku. Inga venalum double bond varala, inga venalum double bond varala, இல்லனா இங்க வேணாலும் double bond வரலாம். So எங்க double bond வரும்? எங்க double bond வரும்? Because it is alpha beta elimination. So alpha beta sideல இருந்து hydrogen and halogen eliminate ஆகுது. Hydrogen and halogen eliminate ஆகும்போது we know that double bond will form. Okay, double bond will form. So inga double bond vena form agala, illana inga double bond vena form agala. Okay, so tell me, ma'am, can you explain again? Yeah, I will tell you, no worries. So I will explain again. So guys, we know that. Okay, so I am using a bulky group. Okay, bulky base. Okay, I am using a bulky base. What is a bulky base? Tertiary alkoxide is an example of bulky base. Okay, tertiary alkoxide is an example of bulky base. Here you can see it is a bulky base. So bulky base, inga this is a beta position. Okay, this is a beta position because it is a alpha carbon. So this is another beta position. Okay, listen carefully. So எந்த சைடுல இருந்து ஹைட்ரஜனை ரிமூவ் பண்ணும்? ஓகே, HX ரிமூவ் ஆகணும் இல்லடா, HX ரிமூவ் ஆகணும்ல. So இந்த சைடுல இருந்து பண்ணி இங்க டபுள் பாண்ட் வருமா இல்லனா இங்க டபுள் பாண்ட் வருமா? சொல்லுங்க. So எங்க டபுள் பாண்ட் வரும்? Yes, I will send the note after the session. Okay, but listen the class carefully. So notes ஒன்னும் read பண்றதுக்கு உங்களுக்கு அவ்ளோ டைம் கிடைக்காது. Okay, side 1 ma'am. Okay, this side. So tell me, what is the reason? What is the reason? In case of bulky bases hindered, beta hydrogen will decide major product. So which beta hydrogen? So idhila endha beta hydrogen will decide major product? Which beta hydrogen will decide major products? So I'm writing 2 product. Okay, so here you will get either this product or this product. So tell me which one is major product? Which one is major product? So left one you are saying this is major product. Why major product and it is minor product? So I am writing why this is major product. So that I already mentioned that more stable alkene is major product. More stable alkene is major product. So inga parunga, inga எவ்வளோ alkenes, okay, less hindered. I will tell you the reason. So less hindered இருக்கணும், okay. So the in case of bulky base, less hindered, listen carefully, less hindered beta hydrogen. Guys, clear? Less hindered beta hydrogen எதுடா? So இந்த beta hydrogen பார்த்தா it is less hindered. இந்த beta hydrogen ல என்ன இருக்கு? Again ஒரு group வருது, okay. Again இங்க ஒரு group வருது. So it is more hindered. Okay, less hindered இந்த group தான், okay, இந்த carbon தான், இந்த hydrogen தான் less hindered இருக்குது. So that it is major product, okay, so that it is major product and it is minor product. Is it clear? Is it clear, guys? Is it clear, Navya? Clear? Got it. Clear? No doubt alla. Then we are discussing another condition, okay, that is states of rule, okay, states of and Hoffman condition, okay, states of and Hoffman condition. So states of, guys, இது bulky group வரும்போது மட்டும்தான் இது வருது, okay, bulky group வரும்போது மட்டும்தான் என்ன இந்த condition வருது, okay, listen carefully, okay. Then we are moving to states of rule and Hoffman, okay. So states of rule and Hoffman, so same I'm taking 1, 2, 3, which I'll, okay. Okay, so here I'm giving X. So same in a or NaOH, okay, NaOH I'm using base. So what will be the product? இங்க என்ன product இருக்கிறதுக்கு chances இருக்கு? Which product? Okay, so which is the product? So which is the product? Tell me quickly. Which is the product? Inga, so I'm not taking, okay guys, listen carefully, I'm not taking bulky group, okay, inga bulky base illa, it's normally alcoholic NaOH, okay, or I'm taking alcoholic KOH, okay, you can take any base, okay, alcoholic NaOH எடுக்கலாம் இல்லனா alcoholic KOH எடுக்கலாம், okay, alcoholic NaOH or alcoholic KOH எடுக்கலாம். Then what will happen அடா? என்ன நடக்கும் இங்க? So என்ன நடக்கும் இங்க? Simple, alcoholic NaOH, alcoholic KOH இருக்கு. So எங்க? This is not a bulky group, listen carefully, the base is not a bulky group. அப்ப என்ன நடக்கும்? Same, இது ma'am beta, இதுவும் beta. So what is your major product? So what is your major product? So either this or this. So tell me what is your major product? Tell me what is your major product? இதா. So நீங்க எப்படி calculate பண்ணணும்? So நீங்க எப்படி identify பண்ணணும் major product? The alkene should be stable, okay, that alkene should be stable. Alkene எப்படி stable ஆன identify பண்ணும்? First one is minor and second one is major. So how we will calculate the stability of alkene? How we will identify the stability of alkene? So it's very simple, I already mentioned that alpha hydrogen. So how many alpha hydrogens are there? This is a I'm using different color. This is a double bonded carbon da. So double bonded carbon direct attach பண்ணி இருக்கிறது தான் என்னடா? Alpha carbon. So alpha carbon ல எவ்வளவு hydrogen இருக்கு? 1, 2, okay. So 2 alpha hydrogen is present, okay. So here you can see 2 alpha hydrogen is present. So here I am taking, so this is our double bonded carbon. So double bonded carbon, idun da double bonded carbons, okay. So in the double bonded carbon attach பண்ணி இருக்கிற carbon is this, and in the double bonded carbon direct attach பண்ணி இருக்கிற carbon தான் இது. So in the carbon molecule, this is alpha carbon. So in the carbon மேல actually 3 hydrogen இருக்கு, in the carbon மேலயும் 3 hydrogen இருக்கு. So total 6 alpha hydrogens are there, okay. Total 6 alpha hydrogens are there. Listen carefully, total you can see 6 alpha hydrogen. So now tell me which alkene is more stable. Now tell me which alkene is more stable, A or B? Butene, this is butene, this is 1, 2 butene. Butene and 2-butene. Butene and 2-butene. Yes, obviously second alkene is more stable. Yes, this is more stable. Okay, this is more stable. Clear alle? Clear? Okay. I hope it's clear. So guys, what is states of product? Okay, what is states of product? Tell me, what is states of product? What is states of, what is? Idile ede states of product, ede Hoffman product. This is actually, what is states of product means more substituted, okay, more substituted alpha carbon irunda, that is states of, okay. So here you can see 2 substituted alpha carbons are there. This is actually states of product. Maybe they will ask, okay, maybe they will ask, write the states of product, okay, they can ask, okay, write the states of product of this molecule, or maybe they will ask, write the Hoffman product of this molecule, okay. Yes, clear alleda? Clear alle? I hope it's clear. Then I will give you one question. You can write the question. Come on. It's a previous year question. Okay. It's a previous year question. So based on mechanism, you can see almost 2-3 questions. Okay. 2-3 questions. Based on mechanism only, you can expect like 2-3 questions. Yes, it's minor. Less substituted alkene, less substituted alkene, more substituted alkene. That is the difference, okay. So C, ma'am, you guys are saying C. Okay, let me check. Okay, so 1-chloro-butane. 1, 2, 3. 1, 2, 3, 4. Okay, butane, 1-chloro-butane. So this is chlorine. Okay, on heating with the KOH. Okay, it's heating with the KOH. Then what will happen? Yes, this is the alpha. This is the beta carbon. So you will get 1, 2, 3 double bond here. Okay, butyronene. Yes, correct. Butyronene you will get. Okay, so assertion. Reason. It is the elimination reaction involving carbonium ion intermediate. Guys, you are getting carbonium ion intermediate. You are getting carbonium ion intermediate. Any carbonium ion intermediates are forming. Carbonium ion intermediate means carbocation, carbanion or carbon free radical. Any carbocation, carbanion, carbon free radicals are forming here? No. So this is correct. This is wrong. So A is correct. A is correct and B, R is wrong. Okay. Clear alle? Then I will give you one more question. I will give you one more question. I will give you one more question. Come on, do it. Not clear. Then I will tell you. In the question, last question, not clear, ada? In the question are not clear. Last question are not clear. Which question? Which question? Which question? Tell me, Zaina. Zaina, in the question doubt irukku. So you guys are saying D. So let me check. Arrange the following alkyl halide in the decreasing order of their beta elimination when treated with alcoholic KOH. Yes, alcoholic KOH. Arrange the following alkyl halide in decreasing order of their, okay. So what will happen, dada? So inge irundhu that I want to so inge irundhu before question. So I will explain last question, then I will explain here, okay? Yes. So assertion enna sonni irukku Zaina. So I will write here assertion. So assertion la so in a 1-chlorobutane is there. So I am writing this is 1-chlorobutane. So 1-chlorobutane is reacting with the KOH. Okay, 1-chlorobutane is reacting with the KOH. Okay, it's normal alcoholic KOH. So normal alcoholic KOH கூட react பண்ணும்போது என்ன நடக்கும்? It's very simple. இங்க இருந்து alpha beta elimination நடக்கும். Okay, so alpha beta elimination நடக்கும். So இங்க என்ன இருக்கு? இங்க ஒரு hydrogen இருக்கு. So இந்த ஹைட்ரஜனும் குளோரினும் இங்க இருந்து எலிமினேட் ஆகி இங்க டபுள் பாண்ட் வரும். So இங்க டபுள் பாண்ட் வந்திருக்கு. கிளியரா? ஓகே, so கிளியர் இல்ல? So and second ரீசன்ல என்ன சொல்லி இருக்கு? It is an elimination. Yes, it is an elimination reaction involving carbonium ion intermediate. What is carbonium ion intermediate? Either it should form carbocation, carbon free radical or carbanion. So அப்ப எப்படி சொல்லலாம்? இதுதான் intermediate. இங்க ஏதாச்சும் intermediate form ஆயிருக்கா? ஒரு intermediateம் form ஆகல. Okay, ஒரு intermediateம் form ஆகல. So அதனால this reason is actually wrong. So assertion is correct, reason is wrong. Okay, correctா? correctடா? correctா? Okay, so correct அல்ல? How can? What is this ada? Meth, eth, prop, but and double bond is there. So what we will say? It is but 1-ene. The product name enada? This is IUPAC naming. Okay, this is but 1-ene. Okay, but 1-ene. Idoda in the molecule oda name தான் but 1-ene, or we can say butene. Butene nu சொல்லலாம், but 1-ene nu சொல்லலாம். But we should follow this naming method. Okay, but 1-ene. Okay, clear ah? Zaina? Then next question alle. This question. So this question le eppadi varum? Yes, this is ena. So I am writing here. Okay, I am writing the molecule here. CH3 CH2Br. Okay, so CH2, here I am writing Br. So what will happen ada? So what will happen? இங்க இருந்து இந்த Br-ம் போகும், இங்க இருந்து hydrogen eliminate ஆகும். Okay, so you can see double bond here. Okay, you can see double bond here. Okay, okay. Then next இங்க எப்படி நடக்கும்? இங்க இருந்து இந்த bromine போகும், இங்க double bond வரும். So இங்க இருந்து இந்த bromine போகும், இங்க double bond வரும். So they ask which one is more stable. Just calculate alpha hydrogen. Just calculate alpha hydrogen. So alpha hydrogen calculate பண்ணுங்க. Which one is major product or which one is more stable? Alpha hydrogen calculate பண்ணுங்க. So இதுல எவ்வளவு alpha hydrogens இருக்கும்? So we know that inga double bond varumbodhu this carbon is directly connected with this carbon. So inga 3 and here also 3 alla 3. Okay, so here we will get 6 alpha hydrogen. Okay, 6 alpha hydrogen is present here. So when you consider here, so inga than double bond varudhu. Okay, double bonded carbon is connected with any other carbon? No. Is double bonded carbon is connected with any other carbon? No. So then 0 alpha hydrogen. Here 0 alpha hydrogen. When you consider this double bonded carbon is connected with this carbon. So this is alpha carbon. So this alpha carbon is connected with the 3 other hydrogen. Okay, so here 3 alpha hydrogen is there. So first one is more, then second C, A, C, B. This is the correct answer, A, C, B. Yes, option D is the correct answer, not option C. Option D is the correct answer. Clear? Option D is the correct answer. Clear? Is it clear? Then we are moving to next is actually dehydrohalogenation allada. So here dehydration. Okay, dehydration of alcohol. Okay, dehydration of alcohol. So what is actually dehydration of alcohol means? So I will tell you. So here we are writing a reaction. Okay, so here you can see alcohol. Okay, ROH. Okay, so H plus oda presence la treat panna pore. Okay, H plus oda presence la treat panna pore. So first step is protonation. First step is protonation. Guys, what is protonation? Tell me, what is protonation? But stability more, reactivity rate is less, ma'am. What they asked? Just a second. This one nalle. In the question dane, Zaina? Zaina, which question? But stability more, reactivity rate is less. Any doubt? Next one, ma'am. How's you saying this, Salada? So, idoda case la you are considering carbocation. Okay, tertiary you are considering ada. So, idile like reactivity jaasti inga da nadakum. Reactivity is also more here. Okay, reactivity more inga da enna stability more anga da. Okay, stability inga more irukku anga da reactivity automatically increase agulla. Okay. Yes. Okay, then so what will happen? Hydrogen inga vanda add agum. So you will get ROH2. Is it stable? No, it is not stable. Okay, it is not stable. So what will happen? This bond will break. It will form H2O. Okay, H2O inga irundhu eliminate agum. Okay, H2O inga irundhu eliminate aayirukku. What will form? Here it will form R plus. Okay, inga R plus. Okay, so that means carbocation. If rearrangement is possible. Okay, guys, if rearrangement is possible means yes, rearrangement will happens. Okay, rearrangement possible irunda rearrangement happens da, and finally you will get alkane. You will get alkene. Okay, so you I'm writing alkene. Alkene. Okay, so finally you will get alkene. Okay, so clear illa? Yadachi doubt irukka? So anga irundhu hydrogen again eliminate agum, you will get alkene. So here the reagent is very important. Okay, here the reagents are very important. Concentrated H2SO4. Concentrated H2SO4 heat pannanu illana H plus oda presence la heat pannanu. Okay, so this is the reagent here. Okay, this is the reagent here. So reaction mechanism padichirukke and important points are very important. Okay, so all the points are very important. Formation of primary carbocation is the rate determining step. Okay, not primary carbocation, first carbocation. Okay, it's not primary carbocation, it is first carbocation. It's written here primary, but it is first. So formation of first carbon before rearrangement irukilla. So before rearrangement ku munnadi irukra andha carbocation da enna that step will determine the rate. Okay, rate determining step. Next, rearrange if possible. Okay, so we know that which carbocation is more stable? Tertiary, then secondary, then primary carbocation is more stable. So rearrange, if rearrangement is possible means you can rearrange. Okay, so in case of carbocation I am saying, okay, in case of carbocation, rate of reaction or reactivity directly proportional to stability of first carbocation. Okay, rate of reaction or reactivity is directly proportional to stability of first carbocation. First carbocation ennada? So rearrangement ku munnadi irukra carbocation. Okay, that is actually rate of reaction sollumbodhu we will consider that first carbocation before rearrangement carbocation. Okay, rate of reaction R is equal to K into R minus O H2 plus. This is wrong. This is plus, this is minus. Okay. So, inga 1. Okay. So, more stable alkene is the major product. Here also, more stable alkene is the major product. Okay. Here also, the more stable alkene is the major product. Okay. Then I will give you one question. You can write the answer. Acidic medium for the reaction maximum. Yes, yes. Amalu. Kaushika B, Vensi B, Zaina B. Okay. So can I write the answer? Or A, Durga is saying A. Navya B, 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 I can see A, yeah, ma'am. Okay. Let me tell you the answer. Okay. So here you can see. Inga in the OH pogum. Okay. Inga in the OH pogum. Obviously, what will form? Here it will form carbocation. Okay. Carbocation form ago. So, carbocation. Which carbocation is more stable? Which carbocation is more stable? So, I am writing here. Okay. I think it's visible. Okay. Is it? Okay. Better. So, carbocation in first 1, 2. So, inga oru carbocation form agudhu. Okay. So, rearrangement nadakudhu and inga carbocation form agudhu. Okay. Rearrangement nadakudhu. Inga carbocation form agudhu. So, here you can see rearrangement nadande inga carbocation varudhu. It is secondary carbocation. Okay, guys. Secondary carbocation. So, when you consider next, so again in a rearrangement nadakudhu inga varudhu carbocation. Tertiary carbocation form ஆயிருக்கு இப்போ. Tertiary carbocation form ஆயிருக்கு. Which carbocation is more stable? Which carbocation is more stable? We know that tertiary carbocation is more stable. It is primary carbocation, it is secondary carbocation, and it is tertiary carbocation. So, clear illa? So, in the tertiary carbocation I am taking, okay? Tertiary carbocation I am taking. So, alpha beta elimination. Okay, alpha illana inga dhaan varum. Okay, beta carbon la dhaan varum. Okay, so inga varalam double bond. Okay, so idoda product either double bond inga varalam. Okay, illana inga varalam double bond. So I will write here. Inga varalam double bond illana inga double bond varalam. Okay, inga vandalum same da. So I am writing here. Okay, I am writing here. So guys, which one is more stable alkene? So you should calculate number of alpha hydrogen. Okay, just calculate number of alpha hydrogen. So here you can see 1, 2, 3, 3, and when you consider this carbon, so here 1, 2, here also 1, 2, 3, 4, 5, 6, 7. 7 alpha hydrogen is there. When you consider this one, so idu consider பண்ணும்போது inga 1, 2, and here also 1, 2, here also 1, 2. So 1, 2, 3, 4, 5, 6. 6 alpha hydrogen. So more stable annada, more stable compound is this. This compound means this is correct answer. Clear? Concept clear? Concept clear? That's important. Okay, is it clear? Is it clear, guys? Durga, clear illa? Yes, more alpha, more stable. Okay. So then I will give you another question. So everything is previous year questions only. Okay, ellame previous year questions da. Come on, write the answer. Okay, Kirtana. Write the answer. Come on, tell me what is the answer. The reactivity order of alcohol toward acid. Reactivity order of alcohol towards acid. Okay. So reactivity meaning actually rate of reaction ada. Okay, reactivity order means it is rate of reaction. Okay. Now same compound. 1 and 3 are same compound. Ah, yes. Okay, then I will give you one double bond here. Now different ஆயிடுச்சுல. Yes, correct. Sleepy actually sleep illa. I can understand. So tell me what is the correct answer? No answer. A, you can see A, option A, C, D. I can see every option now. So now you are learning, I think, alphabets. A, C, D, B is, nobody is giving B. A, C, A, option A. Let me check, okay. So, guys, so when you consider rate of reaction, so rate of reaction eppadi consider pannanuda? So before rearrangement, okay, first carbocation eppadi form agum, so adha base பண்ணிட்டு தான் இருக்கும். Okay, so first carbocation eppadi form agum, adha base பண்ணிட்டு தான் இருக்கும். Okay, so here OH இங்கிருந்து போகும், ஹைட்ரஜன் வந்து H+ அங்கிருந்து போகும், கார்போகேட்டையான் இங்க ஃபார்ம் ஆகும், OH போயிருக்கு, இங்க கார்போகேட்டையான் ஃபார்ம் ஆகும், OH போயிருக்கு, இங்க கார்போகேட்டையான் ஃபார்ம் ஆகும், OH போயிருக்கு, இங்க கார்போகேட்டையான் ஃபார்ம் ஆகும். Which one is more stable? So here this, okay, here you can see resonance is there. Okay guys, resonance is there. So resonance positive, single, double, resonance is there. 3 is more stable. I can eliminate A and B. Okay, 3 is more stable. Then how we will check kada? Here I can check எவ்வளோ alpha carbons இருக்குன்னு check பண்ணலாம். Okay, alpha carbons எவ்வளோ இருக்குன்னு check பண்ணலாம். So alpha carbons இங்க carbocation. So carbocation is directly attached to only one alpha carbon, alpha hydrogen. Okay, so not alpha carbon, alpha hydrogen. When you consider this one, so 3 இருக்கு and இங்க 4. Okay, so இங்க 1 hydrogen, இங்க ஒரு hydrogen. Okay, இங்க 3 hydrogen. So total 4 alpha hydrogen is there. So when you consider this one, so this is the carbocation. So in the carbocation consider பண்ணும்போது, so it's directly connected with 1. Okay, here 1 alpha hydrogen is there. So we know that first one என்ன 3 தான் வருது. First one 3 வருது, அதுக்கப்புறம் 4 வருது. ஓகே, அதுக்கப்புறம் என்னடா 4 இல்ல, ஐயோ, ஃபர்ஸ்ட் ஒன் அதுக்கப்புறம் 3 வருது, பிகாஸ் இங்க 4 ஆல்ஃபா ஹைட்ரஜன் வருதுல்ல. ஸோ 3, ஸோ 3 அதுக்கப்புறம் என்னடா, திஸ் இஸ் 2 அல்ல, this is 2. So I can confirm this is the answer, but I will tell you one more thing. Okay, I can confirm this is the answer. So I can tell you one thing. Here you can see 1 alpha and here also you can see 1 alpha. So 1 alpha வரும்போது confusion ஆயிடுச்சுல. Okay, 1 alpha இந்த questionல ஏதாச்சும் modification வந்து கொடுக்கலாம். Okay, so maybe options. Okay, இங்கேயும் 3 வந்தா நீங்க என்ன பண்ணும், இங்கேயும் maybe 3 வந்திருக்குன்னு நினைச்சுக்கோ, 3 இல்ல 2. ஸோ அப்போ கன்ஃபியூஷன் ஆயிருக்குல்ல. ஸோ அதுக்காக நீங்க என்ன பண்ணணும், இங்க குளோரின் இருக்கு. ஓகே, குளோரின் இருக்கு, குளோரினோட I character. Okay, it is a minus I. Okay, chlorine is actually minus I group. Okay, chlorine is actually minus I group. So chlorine is minus I group means, so minus I group கிட்ட என்ன இருக்கு? Carbocation கிட்ட minus I group வருது. Okay, carbocation கிட்ட minus I group வருது. It is more stable or less stable? It is more stable or less stable? It is actually less stable. Okay, so we know that carbocation, stability of carbocation is directly proportional to plus I group and inversely proportional to minus I group. So this is least stable. Yes, very good. Less stable. Clear? Concept clear? This concept is very important. Okay, actually like last year question on the concept. Okay, so next one, free radical addition. Okay, free radical addition. So it is addition reaction. Okay, we are moving to addition reaction. So I will tell you. So here you can see addition of Br or peroxide. Guys, inga da Zyna danla. Yes, Zyna last question கேட்டிருக்குல மேம் மார்கோனிகோவ் ரூலா அது மார்கோனிகோவ் ரூல் ஃபாலோ பண்ணும்ல. Actually when you consider, that is actually elimination reaction. Elimination reaction there is no Markovnikov rule, there is no anti-Markovnikov rule. Okay, so yes, you only. Okay, so but in case of addition reaction, okay, addition reaction yadachu we are adding. Okay, we are going to add something. Okay, we are adding something. Okay, so inga da enna varum Markovnikov rule and anti-Markovnikov rule. Okay, inga da enna varum Markovnikov rule and anti-Markovnikov rule. Okay, clear? So addition of HBr. Okay, addition of HBr in presence of, listen carefully, in presence of peroxide. எங்க peroxide வந்திருக்கோ அங்க addition இருந்திருக்குன்னா you can just follow anti-Markovnikov rule addition. Okay, you can just follow anti-Markovnikov rule addition. Okay, so or this reaction is also called peroxide effect or Karash effect. Okay, peroxide effect or Karash effect. So mechanism I will tell you. So inge enna irukada per oxygen. Okay, maybe they will give you direct in the madri or molecule taru. Okay, how you will got it ma'am. Okay, so how you will get to know, so here you can see oxygen bond is there. Okay, oxygen bond is there means yeah, it is peroxide. Okay, so what will happen? This bond will break. Okay, this bond will break, and the bond break பண்ணும்போது what will form here? Here free radical will form. Okay guys, free radical form ஆகும். Okay, so free radical form ஆயிடுச்சு. So next இந்த molecule மட்டும் we are going to take. Okay, so two molecules இருக்கு. So again in the phenol group. Okay, phenol group COO free radical again break ஆகும். phenol la enna nadakunda, we will get phenol radical. Okay, we will get phenol radical. Okay, everyone quickly smash the like button. Everyone mark your attendance. Everyone mark your attendance. Come on, I want to see 100 plus likes. Okay, I want to see 100 plus likes. Come on everyone, mark your attendance. I want to see suddenly 100 plus likes. I know you can do that. Because I am taking this much effort. Okay, nice. 79 aidichu. Okay, so here you can see this phenol free radical. Okay, this is phenyl free radical. என்ன ரெண்டு phenyl free radicalum combine ஆகும். Okay, so phenyl free radical என்ன இந்த radical கூட தான், இந்த phenyl free radical கூட தான் என்ன HBr react பண்ணும். Okay, HBr react பண்ணும். So என்ன phenyl கூட HBr react பண்ணும்போது it's very simple. யார் வரும்? hydrogen இங்க வரும் and Br radical இங்க வரும். This is very important. Okay டா. So இதோட mechanism இருக்கு. Okay, இது வரைக்கும் clear தானே? இதுதான் concept and இதோட mechanism. Okay, mechanismத்துல actually two steps இருக்கு. Okay, two steps இருக்கு. I will explain. So I will explain. Here you can see R. Okay, இப்போ நம்ம phenyl தான் எடுத்திருக்கு. So we are taking a alkene group. Okay, alkene. Okay, double bonded group. Okay, we are taking alkene. Okay, alkene molecule எடுக்குது and we are treating with என்ன Br. ஓகே, அந்த Br இங்க இருந்த ஃபார்ம் ஆயிருக்க Br free radical இல்ல. So Br free radical கூட what will happen? This bond will break. Okay, this bond will break, not complete bond. ஓகேடா, சிக்மா பாண்ட் மட்டும்தான் பிரேக், சிக்மா இல்ல பை பாண்ட் மட்டும்தான் பிரேக் ஆகும். ஓகே, பை பாண்ட் மட்டும்தான் பிரேக் ஆகும். ஓகே, ஐ அம் ரைட்டிங் பை பாண்ட் மட்டும்தான் பிரேக் ஆகும். ஸோ ஹியர் யூ கேன் see that electron இங்க வரும். ஸோ homolytic cleavage. ஸோ என்ன ஃபார்ம் ஆகும், என்ன ஃபார்ம் ஆகும், ஃப்ரீ ரேடிக்கல்ஸ் ஃபார்ம் ஆகும். ஸோ யூ வில் கெட் Br கூட ரியாக்ட் பண்ணும்போது என்ன ஒன் சைட்ல Br வரும். ஓகே, we know that it is என்ன anti-Markovnikov's rule, hydrogen peroxide. Okay, anti-Markovnikov's rule. Okay, so என்ன hydrogen என்ன number of hydrogen more இருக்கிற கார்பன்ல யாரு வந்து அட்டாச் பண்ணும், Br will attach. Here you can see free radical is there. So next step la, so free radical is there. So free radical again react with HBr. So HBr break ஆகும். So Br free radical form ஆகும். இங்க hydrogen வந்து attach பண்ணும். Okay, so again இந்த Br again என்ன alkene la போய் attack பண்ணும். So it's a continuous process. Okay, it's a chain process. Okay, it's a chain process. Is it clear, guys? Is it clear? It's a continuous process. It's a chain process. Then I will give you another question. It's AIMS 2009 question, guys. It is AIMS 2009 question. So come on, try. AIMS question na vera level question a irukum. Okay, if you are getting correct answer means very nice. Hari will come and he will say good morning, ma'am, and he will go. And again he will come good afternoon, ma'am, and then he will go. And again he will come hi, ma'am, then he will go. So come on, option A. A. Everyone is. Okay. But-1. Okay. But-1 reacting with the HBr in presence of peroxide. What will produce? So here it will produce. Inga 1, 2, 3, 4. Okay, hydrogen. Hydrogen more Br. Okay, this will be the product. This will be the product. Okay, correct. Doubt irukka? Produces 1 bromobutane. Correct. 1 bromobutane. Yes, assertion is correct. It involving free radical mechanism. Yes, obviously it was involving free radical mechanism. Now only we discussed. So yes, both assertion and reason are correct. And the reason is the correct explanation of assertion. Yes, sir. Yes, sir. Then I will give you another question. Based on the same topic, I am giving a question. How much was we can we can expect like 4 question. Okay, mechanism based 4 question definite varum. Okay, mechanism based or 4 to 3 4 question definite varunda. Mechanism based question. So this is very important. Okay. In evening la night, okay, உங்களுக்கு night class இருக்கு. So உங்களுக்கு எல்லாருக்கும் தெரியும்ல இன்னைக்கு 7. So guys, 7 to morning, okay, 7 today 7 p.m. to 5 a.m. வரைக்கும் உங்களுக்கு complete class இருக்கு இன்னைக்கு night. So நீங்க ப்ராப்பரா ரெஸ்ட் எடுங்க in betweenல. So but you have class. So you have class at 7 p.m. to 5 p.m. 5 a.m. okay. So 5 a.m. So physics class இருக்கும், maths physics class இருக்கும், chemistry class இருக்கும், biology class இருக்கும். Okay, okay, I am waiting. So you guys are saying C. So C, 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 D, D, D. There is a twist. Okay, it's a jipmer question ada. So உங்களுக்கு என்ன வேணும்னு சொல்லுங்க, நைட்ல we will give you. Okay மேம், பொராட்டா சிக்கன் தால் மக்னி அப்படி சொல்லக்கூடாது. ஸோ மேம் ஸ்டார்ட் வித் கெமிஸ்ட்ரி. ஓகே ஓகே, we will try it. Okay, okay, so you guys are saying what is your answer? Your answer is actually C alle. So let me check. Addition of HCl, okay, HCl to propene in presence of, okay, okay, propene, okay, propene, okay, this is propene in presence of peroxide gives, okay, so in presence of HCl and peroxide. Okay guys, very important concept. Okay, so very important concept irukku. Enna concept? So important concept eduna peroxide hydrogen. Okay, HBr kuda peroxide vanda, yes, so effect irukku, but peroxide HCl vanda there is no effect of peroxide. Inga peroxide ku oru effect illa. Okay, so inga peroxide ku ennada HCl kuda varumbodhu there is no effect. It is very important. Then what will happen? It's very simple. This bond will break. Yes, carbocation will form. This bond will break, carbocation will form. So carbocation, which carbocation is more stable? This is secondary carbocation. So it is more stable than primary carbocation. So in the secondary carbocation la yaru varunda? So secondary carbocation la yaru varum? Chlorine varum. Okay, so secondary carbocation la yaru varum? Chlorine varum. Okay, clear? Clear? Verithanam class at 10 hours. Yes, 10 hours Verithanam night irukku. Okay, so what will be the product? What will be the product? Enna question? Addition of HCl to propene in presence of peroxide give chloropropene. No propane. No. It's actually 2-chloropropane. Okay, 2-chloropropane you will get. Okay, so this is wrong. Assertion is wrong. So the reaction occurs by carbonium ion intermediate. Yes, carbonium ion intermediate. Yes, carbonium ion is forming. So this is correct. Assertion is wrong. Reason is correct. Assertion is incorrect. Yes, correct answer is actually option D is the correct answer. புரிஞ்சாச்சா? இங்க என்ன இருக்கு? only HBr ல மட்டும்தான் hydrogen peroxide work ஆகும். Okay, HCl ல என்ன hydrogen peroxide ஓட effect இல்ல. Okay, it is very important. Okay guys, it's very important. Concept clear? When are you guys going to write NEET exam? So May 8th we are going to write NEET exam. Clear alla? So this concept is very important. Okay, this concept is very important. Yes. Next we are moving to nucleophilic addition reaction. Okay, so nama already addition reaction la oru addition reaction solli irukku, HBr oda addition. Okay, now we are moving to nucleophilic addition reaction. Okay, nucleophilic addition reaction, this is also very important. Guys, listen carefully. Okay, so you can see here nucleophile. Okay, so inga aldehyde illana ketone. Okay, we are taking aldehyde or ketone. So aldehyde or ketone reacting with a nucleophile. Guys, we know that carbon is actually partially positive. Okay, nucleophile na we need a electrophilic sender alle. So we need a so we need a electrophilic sender. Okay, nucleophile na we need a electrophilic sender. So in the electrophilic sender, oxygen or carbon? I will use another. So nucleophile is attacking. So இங்க இந்த aldehyde இல்லனா ketonல nucleophilic center யாரு? nucleophilic center யாருடா? So in the nucleophilic center, tell me quickly. See here. Carbon. So I'm thinking about options. Okay. Yes. Why carbon is a nucleophilic center? So I'm not asking nucleophilic center, electrophilic center. So why carbon is electrophilic center? Why carbon is a electrophilic center? So everyone quickly smash the like button. Everyone quickly smash the like button. இப்போ 100 ஆகல. Why carbon is actually electrophilic center? All syllabus concept plus questions. All concept plus question you want in one session. Okay. So why? Okay, bond with electronegative atom. Yes. So guys, we know that carbon is actually partially positive and oxygen is partially negative. We know that. Okay. So this nucleophile will attack this carbon. Okay. This nucleophile will attack this carbon. Okay. Carbon என்ன nucleophile டைரக்டா போய் அட்டாக் பண்ணும். ஓகே, nucleophile போய் டைரக்டா கார்பனை அட்டாக் பண்ணும். அப்ப என்ன நடக்கும்? so this double bond will break. okay, double bond break ஆகும். okay, so double bond, that means a pi bond break ஆகும், not sigma bond, only pi bond. Then what will happen? C single bond O. okay, so this is your positive. So I am not writing now positive. So I am writing nucleophile will attack. Okay, nucleophile will attach. So guys, now the carbon here, the carbon is actually double bonded. It is actually sp2 hybridized. Okay, it is sp2 hybridized, but here it is yes, here it is sp3 hybridized. okay, inga carbon eppadi irukada? sp3 hybridized da. okay, sp3 hybridized. carbon ku inga enna, normally oxygen ku enna minus charge vandirukku. so what will happen next? it will react with the hydrogen. okay, H plus kuda reaction nadakum. so simple ah enna nadakum? H plus kuda reaction nadanda in actually sp3 la irundhu thirupi enna sp2 ஆ மாறணும். okay, so அதுக்காக so I will write here. okay, H plus கூட reaction நடக்கும்போது COH nucleophile, because C and negative தான். so nucleophile and so what will form? Here it will form என்ன? here also it is actually sp3 hybridized. okay, it is also actually sp3 hybridized alcohol will form. okay, here what will form? sp3 hybridized alcohol will form. okay, clear alle? any doubt? mechanism clear alle? then I will give you, I am seeing your message right now only. Hariharan, yes, Hari, new account வந்தா தெரியாதுன்னு நினைச்சியா? good afternoon. okay, then I will give you a question. here is the question. no, it's important points. okay, we are discussing about important points. okay, on the basis of that reaction mechanism we are going to discuss the important points. a nucleophile attack the electrophile carbon atom on a polar carbonyl group form a direct approximately perpendicular to the plane. okay, so inga ennada? inga ella plane sp2, we know that sp3 sp2 nu sonna enna, actually one plane la irukku. okay, sp2 nu sonna ennada? actually one plane la da irukku. okay, so here you can see sp3 hybridized orbital of carbonyl carbon. and second point, the hybridization of carbon change sp2 to sp3. so normally what will happen? inga sp2 da irundhathu, inga enna sp3 ah maarita. okay, so next enna? So next என்ன, this intermediate capture a proton from the reaction medium to give electrically neutral product. So electrically இங்க actually என்ன, oxygenக்கு minus இருந்தது. So oxygenக்கு it's not electrically neutral molecule. So electrically neutral ஆகணும். Neutral ஆனா we know that it is more stable. Okay. After this concept, can you give me 5 minutes break? Okay, I will give you 5 minutes break. So என்ன நடக்கும்? So இங்க electrically neutral ஆகணும். So அதனால it will accept one hydrogen and it will form OH. The net result is addition of nucleophile and H plus across the carbon oxygen double bond. Net result என்ன, அந்த double bond break ஆகி, so அந்த double bond break ஆகி nucleophile attach ஆகும் and H plus attach ஆகும். அவ்வளவுதான். Okay, simple. Simple அல்ல? So yes, I will give you rate of reaction. So listen carefully. Rate of reaction is very important. So here you can see. Okay, so formaldehyde, aldehyde, keton. Okay, so aldehyde, keton irukku. So when you consider steric hindrance, okay, in the molecules high steric hindrance yarukku irukku. So high steric hindrance yarukku irukkuda? High steric hindrance yarukku irukku? சொல்லடா. High steric hindrance, yes, this molecule என்ன high steric hindrance இருக்கு. Why? Because இங்க 2 alkyl group இருக்கு. Okay, alkyl group ஓட number என்ன, can you explain steric effect? Okay, so here you can see steric effect means, steric hindrance means, or the bulky group is there. Okay, bulky group is there. Bulky group is there means we know that electron, okay, electron, already the electron density is also more. So if electron density is more means what will happen? Repulsion is there. Okay, so that is actually steric hindrance. Okay, because of the bulky group. Okay, bulky, because of the presence of bulky group, steric hindrance is more. Okay, because of the presence of bulky group. So here you can see steric hindrance, that means when you consider rate of reaction is directly proportional, inversely proportional to steric hindrance. So or a steric hindrance molecule is there means what will happen? Rate of reaction is less. Okay, rate of reaction decreases. Okay, so when you consider this molecule, so we know that this is less steric hindrance molecule. Okay, because only hydrogen is there. Okay, there is no bulky group, so it is less steric hindrance. Okay, so the rate of reaction is more for first molecule. Then second molecule, only one alkyl group is present. Okay, only one alkyl group is present. Here you can see 2 alkyl group is present. Okay, that is actually keton. Okay, so when you consider aldehyde and keton, listen carefully. When you consider aldehyde and keton, so aldehyde oda steric hindrance is actually less. Okay, aldehyde oda steric hindrance is less, so it is more stable. That means rate of reaction is more in aldehyde. Okay, state of what I'm saying, rate of reaction is more in aldehyde. Why? Because less steric hindrance. Okay, because of less steric hindrance. Clear? Is it clear, guys? Because of less steric hindrance. So when you consider aldehyde, only one alkyl group is there. So obviously less steric hindrance. Clear? Yes, 7 to 5 ada. 7 to 5. 7 to 5. And electronic effect. Okay, electronic effect rate of reaction is directly proportional to electrophilicity. Okay, electrophilicity is directly proportional to electron withdrawing group. Electrophilicity nu sonna enada, anga oru electron withdrawing group irundha mattum dhaan anga electron philicity irukku. Okay, electron donating group irundha electron philicity kammi agum. Okay, is it clear? Then I will give you one question. Okay, then I will give you one question. Try. I will give this question. Okay, HCN react fast with so HCN enga fast react pannum? Why? Why? Can you tell me the reason? Ethanol. Ethanol ada. Ethanol. Par. Proper par. We know that aldehyde ketone. When you consider aldehyde ketone. Aldehyde ketone. Reaction rate more enga aldehyde la dhaan irukku. So ellame ketone. Cyclo. Ketone. Acetone. So correct aldehyde. Ethanol. Acetone. How da? Acetone is a ketone alle. Steric hindrance is less. Yes, very good. So I will give you a 5 minutes break. Okay, I will give you a 5 minutes break. Okay. Yeah. Okay, what is time now? You need a break illana illa break I will give you. So and 25. And out 125. 133 I will give you. எவ்வளோ லைக் ஆயிடுச்சு ஜஸ்ட் செகண்ட். I will explain electrophilicity after the class. Yeah, I'm. So I just want to ask, okay, இன்னைக்கு night class இருக்கு, உங்களுக்கு எல்லாருக்கும் தெரியும்னு நினைக்கிறேன். So chemistryல what you want, okay, you want questions இல்லனா இல்ல கான்செப்ட் வேணுமா இல்லனா I'm planning I will give you one exceptions, okay. So inorganic chemistryல உங்களுக்கு தெரியும் exceptions are very important அல்ல. So I thought I will give you one exception, okay. So exception I will give you, then what you want more means tell me மேம் அது வேணும் இது வேணும் இப்போ கேட்டு வாங்கிக்கோங்க என்ன வேணாலும். ஸோ இதுக்கப்புறம் ஒன்றும் கிடைக்காது. ஸோ எக்ஸாம் முடிய போகுது மேம். கொஸ்டின் ப்ளஸ் வெரி இம்பார்ட்டன்ட் டாபிக் எக்ஸாம், ஓகே. எக்ஸாம்பிள்ஸ் மேம், ஓகே. ப்ரீவியஸ் இயர் கொஸ்டின்ஸ். ஸோ டு யூ நீட் எக்ஸப்ஷன்ஸ் வேணுமா? எக்ஸப்ஷன்ஸ் வேணுமா? இன்ஆர்கானிக் கெமிஸ்ட்ரியில் எக்ஸப்ஷன்ஸ் வேணுமா? Very important topics you discuss, ma'am, okay. Exceptions and formulas, okay. So first I will give you exceptions and trends, exceptions, formulas I will give you in one session, okay. In one session I will give you all formulas, exceptions, and do you want named reaction, complete named reaction again venuma? So important, yes. Exceptions are very important, yes. Reactivity orders, what reactivity orders ada enna reactivity order venum? ஸோ அது நம்ம ஆக்சுவலி ரியாக்ஷன் மெக்கானிசத்துல எல்லாம் படிக்குதுல்ல, நேமிங் ரியாக்ஷன். ஸோ ஐ வில் கிவ் யூ நேமிங். ஸோ ஜஸ்ட் அ செகண்ட், ஐ வாண்ட் டு நோட். Just a second, I want to note ada. Okay, tell me. Named reaction. You predict questions. Okay. Named reactions, exceptions and trends. Trends. 11th topic and PYQs. So 11th topic and PYQs are already given, like you did in CBSE. At a CBSE we can predict questions, but NEET is not like that. But I can say that there is a chance for this question, in the question la irundha chance irukku avlo solla mudiyumda. Named reaction. So I will give you named reaction, exceptions and trends, and physical formulas alla, physical chemistry formulas. Formulas. Then what you want? Formulas and tricks. Okay, I will give you any tricks. Okay, tricks. Resonance. You want resonance again? Inductive resonance ellame 100 times na eduthirukda. Just go and watch my last class ellame. Concept and just glimpse. All concept ada. All concept it's very difficult ellada, because me, Lerin ma'am and Gopika ma'am is taking inductive resonance and mesomeric effect. Okay, I will try to include inductive mesomeric resonance effect, like a short video. And physics la ungalku enna venum? Physics la formulas and application. And important formula and application. Any other thing? Important formula, ma'am, help to score at least ray optics. Numericals with the important formula. Numericals. Biology. Yeah. Okay, 12th. Okay, wave optics, ray optics. Okay, finish. Okay, tough numericals. Okay, tough numericals. Toughest numericals. And then what do you want? Biomolecules. Chemistry pannunga ma'am. Okay, biomolecules question I will give you. Okay. Biomolecules question. So I will give you Chemistry la named reaction exception trends. Okay, named reaction exception trends I will give you. And next la trick edachu irundha I will give you tricks and all. And memorize formula in chemistry. Chemistry, okay, ivlo formulas, physical chemistry formulas I will give you. Tricks to remember, edachu remember pandradhukaga tips also, tricks also I will give. Okay, then now we are moving to next. Okay, so 120 likes ஆயிடுச்சாடா, 120 likes ஆயிடுச்சா, 120 plus likes ஆயிடுச்சா. So we can start 102 da. I'm so sad. So yes, so we can move to next substitution reaction. Okay, so substitution reaction na enada, like இங்க ஃபுட்பால் எல்லாம் தெரியும்ல, யாருக்காச்சும் ஃபுட்பால் தெரியும்ல. ஸோ we will substitute. Okay, ஸோ ஒரு ஆளை ரீப்ளேஸ் பண்ணிட்டு வேற ஒரு ஆள் வரும்ல, that is actually substitution reaction. Same also here also it is same. We are substituting. Okay, we are substituting. Okay, so that is actually substitution reaction. Okay guys, so here you can see first one. So I am using this only. Okay, so here we are using benzene and electrophile. யாரோ electrophilicity கேட்டிருக்குல்ல, football only. Yes, யாரோ என்கிட்ட electrophilicity கேட்டிருக்கு, I don't remember. யாரு electrophilicity, யாரு now I யாரு நான் late. அடா, who asked electrophilicity? Me. Okay, then I will tell you what is electrophilicity first. Okay, so because எல்லாமே important தான். Okay, so எங்க electrophilicity சொல்லி தரும். So guys, what is actually nucleophile and electrophile means? What is actually electrophile? We know that electrophile, we will say yeah, it is electrophile. Electrophile means it is electron loving. Okay, electron romba ena love pandradhu da electrophile. Okay, it's electron loving. Okay, so electron loving da ena electron loving. So I will write here. Okay, electron loving species, electron loving species. Okay, so electron loving species da என்னடா electrophile. So அந்த ability இருக்குல்ல, so electron loving species na என்னடா, அதோட electron கம்மியா இருக்கணும். Okay, electron density கம்மியா இருக்கணும். Okay, electron density எப்படி இருக்கணும், கம்மியா இருக்கணும். electron density ரொம்ப கம்மியா இருந்தா என்ன, அதுக்கு ரொம்ப அட்ராக்ஷன் இருக்கும் எலக்ட்ரான் மேல. ஓகே, எலக்ட்ரான் டென்சிட்டி ரொம்ப கம்மியா இருந்தா ரொம்ப அட்ராக்ஷன் இருக்கும் எலக்ட்ரான் மேல. கிளியரா? ஸோ அதுதான் எலக்ட்ரோஃபிலிசிட்டின்னு சொல்லும். ஓகே, எலக்ட்ரோஃபைலோட எபிலிட்டி இல்ல. ஸோ எபிலிட்டி ஹை எலக்ட்ரோஃபைலோட எபிலிட்டி தான் எலக்ட்ரோஃபிலிசிட்டின்னு சொல்லும். ஓகே, எலக்ட்ரோஃபைலோட எபிலிட்டியை we will say எலக்ட்ரோஃபிலிசிட்டி. கிளியரா? கிளியர் மகஸ்ரீ? கிளியரா மகஸ்ரீ? யாரோ கேட்டதா ஒரு ஞாபகம் இருந்தது, ஸோ அதனால இப்பதான் எலக்ட்ரோஃபைல் பார்த்த போது. கிளியர்? ஸோ எலக்ட்ரான் டென்சிட்டி ரொம்ப கம்மி ஆகும் போது என்ன, எலக்ட்ரோஃபிலிசிட்டி இஸ் மோர்னு சொல்லும். எலக்ட்ரோஃபைல். ஓகே, கிளியர்? Okay, then we are moving to electrophilic substitution reaction. So electrophile is there. So electrophile benzene ring கூட react பண்ணும்போது what will happen? Obviously, so இங்க டைரக்டா வந்து electrophile attach ஆகும். because என்னடா electrophile னா என்ன, electron loving species. okay, electron density is very less. but in case of benzeneல super இல்ல, double bond, alternate double bond இருக்கு and high density இருக்கு. so அங்க இருந்து one hydrogen replace பண்ணிட்டு who will come? electrophile will come. so that is actually substitution reaction. okay, that is football னு யாரோ எழுதி இருக்குல்ல, ஹரி மலையாளத்துல. yes, same thing here also we are substituting. okay, இங்க இருந்து ஹைட்ரஜனை substitute பண்ணிட்டு யார் வருது, electrophile வருது. that is actually electrophilic substitution reaction. so என்ன, H plus form ஆகும். okay, H plus form ஆகும். and இதோட mechanism என்னடா, mechanism என்ன, so என்ன, first என்ன, electrophile வந்து attack பண்ணும். okay, electrophile வந்து attack பண்ணும். so here you can see that இங்க electrophile வந்து attack பண்ணும்போது electrophile இருக்கு, hydrogen இருக்கு. okay, and sp3 ஆயிருக்கு. okay, sp3 actually இங்க we know that இந்த கார்பனோட hybridization என்ன, இந்த கார்பனோட hybridization என்னடா, what is the hybridization of this carbon? We know that it is sp2 only. okay, it is sp2 only. so இங்க வரும்போது என்ன இருக்கு, இங்க ஹைட்ரஜன் இருக்கு. okay, இந்த டபுள் பாண்ட் பிரேக் ஆயிருக்கு. okay, டபுள் பாண்ட் தான் பிரேக் ஆயிருக்கு. ஹைட்ரஜன் ஃபர்ஸ்ட் ஸ்டெப்ல ஹைட்ரஜனை ரீப்ளேஸ் பண்ணல, ஃபர்ஸ்ட் ஸ்டெப்ல டபுள் பாண்ட் பிரேக் ஆயிருக்கு. சோ அப்போ என்ன, இங்க என்ன ஆயிடுச்சு, sp3 ஹைபிரிடைஸ். ஓகே, சோ கார்பனோட இப்போ என்ன, கார்பன் எப்படி இருக்குடா, சோ 1 பாண்ட்ல electrophile, 1 bondல hydrogen and again carbon bond. okay, so what will happen, carbocation will form, double bond break ஆயிடுச்சுல, so obviously what will form, carbocation will form. so guys இங்க sp3 hybridized தான், அதுக்கு என்ன திருப்பி sp2 hybridization வேணும். okay, so sp2 hybridize ஆகணும். அப்ப என்ன நடக்கும், இங்க இருக்கிற ஹைட்ரஜன் என்ன, இங்க இருக்கிற electrons இங்க போகும். ஹைட்ரஜன் அல்ல actually, அங்க இருக்கிற இன்வால்வ் பண்ணி இருக்கிற அந்த electrons எங்க போகும், இங்க போகும். so it will form double bond. so இங்க இருந்து ஹைட்ரஜன் எலிமினேட் ஆகும். அது செகண்ட் ஸ்டெப்ல தான் நம்ம we will think, yeah, first stepல hydrogen will eliminate. no, first carbocation will form, then hydrogen will eliminate. clear? first carbocation will form, then hydrogen will eliminate. so here I want to add two more points. If that benzene group, okay, benzene group mela one group is attached. okay, benzene mela one group is attached. The speciality of group is either plus m group இருக்கலாம், இல்லனா minus m group இருக்கலாம். okay, plus m group இருக்கலாம், இல்லனா minus m group இருக்கலாம். okay, suppose plus m group na, we know that plus m group oda direction என்ன, what is the direction of plus m group? it is ortho para directing. okay, plus m group is actually ortho para directing. so we can say that either ortho side la illana para side la this electrophile will attach. okay, so the electrophile will attach in either ortho or para side. so when you consider minus m effect, so it is a meta directing. so what will happen, the electrophile will attach in meta position. so my next question, this is another condition. okay, my next question is, plus m group is there and minus m group is there. okay, so one benzene ring contain plus m and minus m, then what will be the product? electrophile. you can expect, okay, electrophile. so plus m வரும்போது we know that it is ortho para directing. okay, so when you consider minus m வரும்போது we know that it is meta directing. okay, set. then we can assume that in one benzene molecule one plus m group is there, one minus m group is there. then what will be the product if that molecule react with a electrophile? so you guys are saying opposite plus m group, what புரியல, para. okay, so high priority. okay, high priority எங்க இருக்கும்டா, plus க்கு தான் high priority. okay, high priority எங்க இருக்கும், plus க்கு தான் high priority இருக்கும். so then what will happen டா, so high priority plus 1 க்கு இருக்கும், plus m க்கு இருக்கும், I am saying plus 1. high priority plus m க்கு தான் இருக்கும். so it is actually ortho or para directing. ortho or para directing. clear? electrophile will attach opposite to, no, it's ortho or para directing. okay, ortho or para directing. okay, when you consider plus m and minus m இருந்தா it is actually ortho or para directing. okay, high priority அங்க என்ன இருக்கு, யாருக்கு இருக்கு? okay, clear? இது வரைக்கும் clear? okay, then understood ma'am. okay, then we are moving to rate of reaction. okay, and the reaction order, rate of reaction is very important. okay, so rate of reaction is directly proportional to electron density. okay, rate of reaction is directly proportional to electron density. Okay. So, electron density சொல்லும்போது நமக்கு தெரியும். Electron density is directly proportional to plus M, plus H and plus I group. Okay. So, plus M, plus H, plus I group. Yes, correct. So, dominating effect தான் இங்க important. Okay. Dominating effect இங்க எங்க இருக்குன்னு. Okay. So, this is phenol. So, phenol which group is dominating? Minus IR plus IR. We know that. Obviously, it is plus I group. Okay. Plus I group தான் phenol இருக்கு. Okay. So, when you consider aniline. So, aniline எது group dominate ஆயிருக்கு? So, plus H group தான் dominate ஆயிருக்கு. Okay. Plus I விட. So, benzene. Okay. So, when you consider chlorine நமக்கு தெரியும் plus I இருக்கு plus M இருக்கு, but the dominating group is actually plus I. We can ignore plus M. Okay, we can ignore plus M. So when you consider nitro group, okay, nitro group minus M. Nitro group is a minus M and minus I group. Okay, dominating group and a minus M group. Okay, so இங்க actually என்ன electron density plus M plus H plus I ல தான் இருக்கு. So plus M. This is actually plus M group. So இதுக்கு high. And here also it is plus H group. So high. Benzene adukaprom and chlorine வருது. அது actually minus I and it is minus M. Okay. Minus I minus M வரும்போது first priority என்ன I க்கு தான் வரும். அதுக்கப்புறம் தான் M வரும். Okay. Clear? Clear? I hope it's clear. Clear ஆடா? So priority you should check, okay? Yeah, okay, I will tell you again. So listen carefully. Rate of reaction, okay, when you consider a mechanism irunda, rate of reaction is very important. So here the rate of reaction is directly proportional to priority order, ma'am. Yes. That is electron density, okay? Okay, so rate of reaction is directly proportional to electron density. So, on the electron density order da idu, okay? So, plus M, plus H, plus I, okay? Okay, so idukapra yaru varu minus M, minus H, minus I, okay? Okay, clear? So, dominating effect, okay, dominating effect la, so okay, plus M, plus H, okay, here we know that. So, when you consider phenol OH, we know that it will show minus I effect, okay, OH and minus I effect show pannu, and it also show plus I effect. Why plus M effect? Why? Because we know that it contain lone pair of electron, okay, lone pair of electron means it will show plus M effect also. So, when you consider this plus M and plus I. So, plus M da dominating, okay, plus M da dominating. So, we can ignore minus I, okay. So, electron density order, dominating order சொல்லும்போது we can consider plus M effect, okay. So, when you consider CH3. So, CH3 லேயும் என்ன இருக்கு? Plus I இருக்கு, plus I effect இருக்கு, plus I effect இருக்கு, plus H effect இருக்கு, okay. So, இதுல dominating எப்படி சொல்லலாம்? So, second dominating என்ன? Plus H க்கு தான், okay. Second domination எங்க இருக்குடா? Plus H க்கு தான். அதுக்கு அப்புறம் தான் plus I வருது, okay. Next benzene normally we will consider because இங்க என்ன plus group இருக்கிறதுனால, okay. Benzeneல group இல்ல. So, when you consider chlorine, so chlorine la here you can see minus I group irukku plus M group irukku, okay, listen, minus I group irukku plus M group irukku. So chlorine oda case la we will consider priority order varumbodhu this plus M group da high prior ah edukum, okay. Okay, so this is less priority, okay, dominating inga plus minus I da, okay, plus M illa minus I da. So, when you consider NO2 la minus M irukku, minus I irukku, okay, minus M and minus I varumbodhu minus M க்கு தான் priority இருக்கு. Yes ma'am, which module is? Clear? Settle? So, we can ignore this less prior. Okay, yes, இதுல minus I plus m. So we can ignore. Clear? Okay. So guys, SN1 SN2 reaction உங்களுக்கு already தெரியும்ல. SN1 SN2 reaction already ஒரு 100 times I think நான் எடுத்திருக்கு. So அது explain பண்ண வேண்டால. Minus I in chlorobenzene, yes. எடா plus m normally group தான் வரும். So plus m னா என்ன? Plus m னா it should contain lone pair அல்ல. So lone pair இருக்கு, but ஆனாலும் we will consider it as minus m தான், minus I தான் இங்க high priority எடுக்கும் plus m விட. Okay, so அது priority order பார்க்கும்போது, okay, electron density பார்க்கும்போது, okay, electron density and priority order பார்க்கும்போது, okay. No ma'am, SN1 SN2 we know. Okay, so guys, SN1 SN2 எடுக்க வேண்டாம்ல. SN1 SN2 எடுக்க வேண்டாம்ல. Clear அல்ல SN1 SN2? No ma'am. So I will share this PPT. You can study. Okay, you can, if you want, you can just check SN1 SN2. Okay. So SN1 SN2 again repeat பண்ணனுமா? Clear. SN1 SN2, yes, yes. SN1 SN2 already நான் எடுத்திருக்கு. Okay, then I will share. I know SN1 SN2 and everyone please tell me SN1 SN2. Zaina and Sleepy, Amulu, tell me. So cute name. Once again please. Ennada Nathan Kukka time. Okay, இது complete ah? Okay ma'am, slightly revision. Okay, I will do. Okay, no issue. First one is elimination. Elimination la E1 and E2 elimination is there. Okay, so when you consider E1 elimination means E1 elimination la I will use this. When you consider E1 elimination la HX da inga irundhu eliminate agudhu. Okay, E1 elimination la yaar eliminate agudhu? HX. So it is also not E1, E2 elimination. So HX is eliminating. Okay, so that is the reason we will say E2 elimination is also called dehydrohalogenation or beta elimination or alpha beta elimination. So idhula alkyl halide la irundhu alkene kadaikum. Okay, double bonded carbon kadaikum. Okay, so இங்க ஹாலஜன் பக்கத்துல இருந்து கார்பன்ல இருக்கிற, ஓகே, ஹாலஜன் பக்கத்துல இருக்கிற கார்பன், இது ஹாலஜனோட கார்பன். சோ ஹாலஜனோட பக்கத்துல ஒரு கார்பன் இருக்கும்ல, சோ அந்த கார்பன்ல இருந்து ஹைட்ரஜன் போகும், பக்கத்துல இருந்து ஹைட்ரஜன் அண்ட் ஹாலஜன் போகும். ஓகே, சோ that is the reason it is alpha beta elimination we will also called. Okay, so here we will use reagent. So reagent is also very important. So here the reagent is alcoholic KOH or alcoholic NaOH. Okay, or we can use ROK or Na. Okay, ROK or Na. Okay, this is or. Okay, this is or. So I will. Yes. Okay, RONA or ROK. Okay, clear? Then here I will tell you. So there is some condition. Okay, இது எல்லாமே there is no carbocation, carbanion, intermediates ஒன்னும் form ஆகல. Here you can see transition state only, and இங்கே included ஆயிருக்கிற இந்த 5 atoms one plane ல இருக்கணும். Okay, it should be in one plane ல இருக்கணும். And reaction, okay, rate of reaction with respect to Rx. Okay, Rx நமக்கு தெரியும், இங்க இருந்து iodine ஈஸியா எலிமினேட் ஆகும். ஓகே, iodine ஈஸியா எலிமினேட் ஆகும். ஸோ அதனால ஈஸியா இங்க தான் ரியாக்ஷன் நடக்கும். ஸோ when you consider reaction with respect to stability of haloalkene, okay, so rate of reaction எப்படி சொல்லலாம்? So which alkene is more stable, so அது அந்த ப்ராடக்ட் தான் ஃபார்ம் ஆகும். ஓகே, so next is order and molecularity. Here it is stable. 2 and more stable alkene is the major product. Okay, more stable alkene எப்படி calculate பண்ணனும்? So identify பண்ணனும். You can calculate alpha hydrogen. Okay, you can calculate alpha hydrogen, number of alpha hydrogen இருக்கும். So அதை வச்சு identify பண்ணலாம். Okay, so next என்னடா? Next here you can see, நான் இங்க already சொல்லியிருக்கு, you can see, you can use, okay, R RONA, okay, RONA ki badala we are using a tertiary alkoxide, okay. What is the speciality of tertiary alkoxide? Tertiary alkoxide is a bulky group, okay. So normally what will happen, steric hindrance is more in tertiary alkoxide, okay. So here you can see tertiary alkoxide la more steric hindrance is there. So then how the product will form? It is very simple. So less hindered beta hydrogen is the major product, okay. Here you can see this is one beta and this is another beta. So in the beta hydrogen la vera carbons branches onnume illa, but in the beta la vera branch irukku. So if they are giving tertiary alkoxide, just check in a less, okay, just check less in a less hindered, okay, less hindered idu. Okay, so inga double bond varu. So this is the major product. Clear? Clear? Next, this is alkoxide, this is major product, minor product, and next is states of rule and Hoffman alkene. So maybe they will ask, okay, yes, write the states of product, okay, write the states of product. Maybe they'll ask, write the Hoffman alkene product, okay. They can ask, Kallada. So what will happen? Here you can see halogen is there, okay. So this bond will break, either inga double bond varla illana inga double bond varla. So states of la more substitute, okay, states of na enada, it's more substituted carbon ah irukano. So inga parunga states of la inga more alpha, inga 2 alpha carbons irukku, okay, in the double bond mela 2 alpha carbons are there. So states of product is the more substituted alpha carbon. So what is Hoffman product means? Less substituted alpha carbon, and then we can say it is Hoffman product, okay. Hoffman product le less substituted alpha carbon irukku, okay. I need revise, okay. After this I will tell you, okay. After this revision I will tell you, okay. Recall pannadukapra I will tell you, okay. So bro, idu okay la. So next is second method, okay. Second enga pochu, even elimination. Even elimination la water da eliminate agudhu, okay. E2 la HX eliminate agudhu, E1 la water eliminate agudhu from alcohol. So alcohol irukku, so hydrogen வந்து attack பண்ணும், அப்ப என்ன கிடைக்கும்? Water கிடைக்கும். So இங்க இருந்து water eliminate ஆகும். So அதுக்கு அப்புறம் what you will get? Carbocation கிடைக்கும். So if it is rearrangement possible means rearrangement will happen, okay. So then you will get alkene, okay. Then what is the final product? You will get alkene, okay. So here you can see if double bond is means rearrangement is there means rearrangement will happen and you will get alkene. Everyone quickly smash the like button, okay. Quickly smash the like button da. So next, formation of first, here you can see that formation of first carbocation is rate determining step. What is formation of first carbocation means? So we will do rearrangement alle. So before that a carbocation will form alle. So that carbocation will like what? It is actually rate determining step, okay. So rearrangement if possible means yes, rearrangement will happen. Rate of reaction, reactivity is directly proportional to stability of first carbocation, okay. So here in a ROR, okay, ROR is directly ROR is equal to K into, so K R plus OH2 minus form agudilla. So here you can write more stable alkene is the major product. Here also more stable alkene is the major product. Next is free radical addition reaction. So addition reaction now we are going to add something, okay. So elimination la angarde eliminate agudhu and we are getting alkene. So addition reaction la add agudhu, okay. So add agudhu. So here we are doing HBr add pannadhu, okay. HBr we are adding. So here we are taking, okay, general or equation edukumbodhu alkene edutha enna nadakum. So negative addendum enga irukko, negative addendathila yaar attach pannum? Enki test undu madam njan pogute. Yeah Hari, yeah sure. So enna yes alkene kuda HBr add பண்ணும்போது we know that Br என்ன free radical மாறும். So இந்த Br போய் attack பண்ணும். So you will get carbon free radical. So carbon free radical again it's reacting with HBr. So இங்க என்ன வரும்? Hydrogen வரும். So it's a two-step reaction, okay. So two-step reaction. Is it clear? Then next, nucleophilic addition reaction. Okay guys, nucleophilic addition reaction. What is actually nucleophilic addition reaction means? So here we are using ketone or aldehyde. Okay, so nucleophile is adding. So nucleophile add பண்ணனும்னா அங்க electrophile இருக்கணும். So who is the electrophile here? So carbon is the electrophile here. So nucleophile direct carbon மேல வந்து attach ஆகுது. So இங்க என்ன? அப்போ என்ன? Double bond break ஆகணும். So that means pi bond will break. Okay, not complete sigma bond, pi bond only break. So what you will get? You will get a sp3 hybridized carbon. Okay, you will get a sp3 hybridized carbon, and inga oxygen ku enna? Oxygen will get negative charge. Okay, oxygen will get a negative charge. So it is electrically enna? Neutral illa. Okay, it should be electrically neutral. Then what? It will accept one hydrogen from that solvent. So what will form? It will form OH. Okay, here it will form OH. Then rate of reaction. Here the rate of reaction is, if steric hindrance is more means like rate of reaction is less. Okay, so rate of reaction is inversely proportional to steric hindrance. Okay, so yes, so when you consider steric hindrance ketone ku jastiya irukku, so less rate of reaction. So aldehyde ku steric hindrance as compared to ketone, it is less. Okay, so when you consider aldehyde and ketone, it is less. Electronic effect. Okay, electronic effect, rate of reaction is directly proportional to electrophilic. Okay, electrophilicity. I told you what is electrophilicity. Okay, so it's directly proportional to electron withdrawing group and inversely proportional to electron donating group. So next is substitution reaction. So substitution reaction, the first substitution reaction is electrophilic substitution reaction. So what is substitution? If addition reaction finish pannita, next we are discussing about substitution reaction. So here we are eliminating one element, or we are replacing one thing, and one like electrophile is adding. Okay, so one electrophile is replacing. Okay, one electrophile is actually replacing, okay, one nucleophile or something hydrogen. So here we can see that, okay, nucleophile and electrophile என்னடா இங்க வந்து டைரக்ட்டா அட்டாச் ஆகுது, அங்க இருந்து ஹைட்ரஜனை ரீப்ளேஸ் பண்ணுது, அதுதான் நமக்கு தெரியும். ஓகே, ஹைட்ரஜனை ரீப்ளேஸ் பண்ணுது. ஆக்சுவலி அதெல்லாம் மெக்கானிசம். ஃபர்ஸ்ட் this electrophile will attack. So we know that here the carbon is actually, this carbon is actually sp2 because it's benzene only. So yes, now the carbon will become sp3. Okay, so the double bond break. Okay, the double bond is break. Okay, so that means pi electron. Okay, so pi bond is broken. Okay, so then what will happen eda? So idukku enna? sp2 da mudiyum. Okay, so that carbon is actually stable in sp2. So then what will happen? This carbon, inga carbon hydrogen electrons irukulla, so and the electrons inga double bond shift agum. Okay, double bond shift agum, inga irundha hydrogen eliminate pannum. Okay, so it will become, again it will become sp2. Okay, it will become sp2. So this is actually electrophilic substitution reaction. So electrophilic substitution la two conditions da irukku. Already benzene mela oru plus m group illana minus m group varudhu. So we know that plus m group, it is ortho para directing. So this electrophile will attach either ortho or para side. When you consider minus m group is a meta directing. So this electrophile will attach in meta position. Electrophile will attach in meta position. Suppose ஒரு molecule, that means ஒரு benzene மேல negative M and positive M group is there, then what will happen? We know that more prior is plus M effect. Okay, plus M group is high priority. So it will follow either meta position or para position, because plus M is a ortho meta para directing. Ortho para directing. Say ortho meta para directing. So ortho and para directing. So either ortho illana para side la vandu attach agum. Then what? Then rate of reaction. So rate of reaction is directly proportional to electron density, and electron density is directly proportional to plus m plus h and minus I. So this is the dominating effect. Clear ada? Clear? So tell me, clear? Okay, I will share this PDF. Okay. Okay guys, all the best. ஸோ உங்களுக்கு நெக்ஸ்ட்டு லெரின் மேமோட கிளாஸ் இருக்கும். ஸோ ஐ ஹோப் பை பை. இட்ஸ் கிளியர். ஐ வில் ஷேர் த பிடிஎஃப். ஓகே பாய். அண்ட் இன்னைக்கு நைட்டு லைக் நைட் 7 to நாளைக்கு 5 வரைக்கும் கிளாஸ் இருக்கு. எல்லாரும் மேக்ஸிமம் அட்டென்ட் பண்ண பாருங்க. அண்ட் ப்ராப்பர் இன் பிட்வீனில் ப்ராப்பர் ரெஸ்ட்டும் எடுங்க. ஓகே ஓகே பை பை. பாய்டா.